I'm a scientist and not much of a salesman, so I've been, I've been in the development of nutritional and skincare products in the anti-aging field. I've worked for a lot of companies that you've heard of, but anyway, about 20 years. Really quickly, this is a basic cartoon of the skin. And in the old days, they only like to concentrate on a couple things. But if you took a pin and stuck it through your skin from the top down, can everybody hear me without the mic?
Yes.
No? Okay. It would go through these layers. The first layer is called the stratum corneum, or the horny layer. We call that the Mark Sane layer at Alivamax. This comprises the epidermis, which is the cellular part of the skin. Underneath is a structural scaffolding called the dermis, and the fibroblasts are the key cells here. And then underneath that is the fat layer, which is a very important layer because it gives color and cushion and texture to the skin. But the collagen and elastin layers are very important. And underneath all of this is the muscle structure. So what I want to get at really fast is, without getting too deep, is that we're targeting all four layers. We're targeting the cellular turnover in the epidermis through what are called matrikines. And they are cytokines, which are cellular active agents that actually stimulate cells to produce collagen and elastin faster, and also to turn over quicker. Now, aging is the thing that we're trying to stop here, as we've talked about. The cells in your body are all the same, if you're old or young. The difference is signaling. The difference is programming. And what happens, the cell, it's like a factory. I try to explain it this way all the time. If you turn on the machines and you give the raw materials and put the workers on the line, you produce whatever you're making, like cars. You can produce cars. If you want to speed it up, you add more raw material, you add more labor, and you get more cars out the other end. Cells are the same, whether you're young or old. The problem is signaling. There's no manager telling the people what to do, organizing the raw materials and bringing them in. Okay? So what we do with these cells is we find out what triggers them to act and look younger, to act and be younger, and that's what we give them. When I started this 20 years ago, it was lanolin, and that was it. You put lanolin and petrolatum or Vaseline on your skin, and it made it feel better. Now we've gotten into biotechnology, gene expression. We are adding enzymes to the skin and delivering them to the nucleus of cells in this layer here and also here. We're adding ingredients that slow down muscle contractions in the layers below. Okay? And remind me to get to why that's important. But in a nutshell, we're trying to reprogram cells to look and act like they did when they were youthful. I'll skip this. This is kind of the histology of it all. Can you tell me which one of these slides represents old skin and which represents young skin? I mean, if you've never seen a histological slide of the skin before, you can tell instantly that this is the epidermis I was talking about. Notice that in the old skin, it is thinner and also flat. In the young skin, it's undulating. And this goes to surface area, connection. The cells, these are the cells that we're always talking about, cell turnover. You hear that in commercials and such. Cell turnover starts here, goes up to the top, maturity, and then the skin sloughs off. In an aged individual, this takes 28 days to the cell to be born, age, come up to here, and slough off. I'm sorry, in an aged individual, that's 28 days. In a young person, this takes 18 days. Okay, so when it slows down, you get this thinning of the epidermis, and the flattening of the epidermis. Also, collagen and elastin production slows down as we age. And the key here is we can reprogram these cells through cellular mediators to act like they were when they were younger. And getting rid of wrinkles, like we talked about the thinning of the epidermis, is like blowing up a balloon. You increase the biomass underneath the skin with collagen and elastin and cells, just raw cells, and it's like blowing up a balloon to get rid of wrinkles. That's one of the strategies. Skipping. This is actually a study. It's not the same that you looked at, old and new. This is how it started. This is from a plastic surgery patient where they take, when they're done with the plastic surgery, they actually take some skin away from both sides. So what they did was they had the active ingredient in the serum put on one side of the face and not on the other. After a month, they took these two pieces and look at them under the microscope. This is the same skin as this. Okay? What happened? Increase in collagen and elastin production, increase in cell turnover. Is that making sense? Kind of real quick. Okay, now we're going to skip quickly to, that looks boring, doesn't it? We'll skip that. This is, Mark, do you want me to talk about this or skip it? Okay, this is a motor neuron. What a motor neuron is basically the nerve attachment to, this is a muscle cell, and this is a muscle cell here with the nerve attaching, okay? And this is the motor neuron here. And what happens is you have neurotransmitter. You have an electrical signal travel from your brain down your arm or wherever it's going to move the muscle. Everywhere that there's a synapse between the nerve and then the nerve and the muscle, there is a neurotransmitter released, and then it causes the contraction of the muscle. This neurotransmitter must be signaled from an electrical signal. It must then be brought down to the junction here, called the synapse, release its contents, travel across to the receptor on the muscle, then activate the receptor and cause the contraction. In order for this to happen, there's a complex called snare complex that must be assembled every time. It's a combination of 4 proteins. Well, in this, these 4 proteins is a protein called SNAP25. And if you look on the in the ingredient decks of our product, we have this thing called SNAP8. What does SNAP8 do? It mimics SNAP25. And what that does is it's a competitive inhibitor for the formation of this protein complex. If it gets in here, SNAP25 assembles instead of SNAP8 assembles instead of SNAP25, the neurotransmitter will not get released, okay? And that's significant because we're trying to slow this down. Why are we slowing it down, okay? We're slowing muscle contractions down in the face. Everybody heard of Botox, right? You understand why Botox is important. I have a 78-year-old mother who, I have a 78-year-old mother and a 7-year-old daughter. My 7-year-old daughter laughs and smiles all the time. And she crinkles her eyes and her face all the time. No crow's feet and no laugh lines, right? My 78-year-old mother never smiles and never laughs anymore. But she has deep, deep crow's feet and profound wrinkles on her face. Why is that? It's because the mechanical action of the muscles constantly contracting causes the wrinkles that we have on our face. if you paralyze the muscle with Botox, like they do, the stars do, you cannot move this muscle anymore. So the lines go away, okay? And it's because my 7-year-old daughter naturally can repair that damage of the constant crinkling. My 78-year-old mother cannot. So her wrinkles get deeper and deeper. And it comes from the constant stretching of the collagen. Finally a strand breaks, and then another one breaks, and they are not able to be repaired, so the wrinkle gets deeper and deeper and deeper. So what we want to do is we want to slow down the intensity and the frequency of these muscle contractions. So what we have in the serum is 3 methods of slowing this down. This is one of them, the SNAP-8. The other one is actually from this animal here. It's not from the animal, it's actually an analog, a biomimetic analog of the snake venom of this animal called the temple viper. The temple viper gets its name from, it lives in a temple in somewhere in Malaysia. Biomimetic means it's exactly the same as this venom component of the temple viper. Why did we choose that? Because it's reversible. Botox is not reversible. It paralyzes the muscle, and the muscle atrophies when it comes back. Maybe 80% you gain. If you do it over and over, you're losing. You're atrophying the muscle, and you may never get any of it back, any of the contraction, the ability to contract back. Why we chose the temple viper is completely reversible and safe. Okay? And it works here. So SNAP 25 works here, or SNAP-8 works here. The temple viper venom actually works at the receptor site on the muscles. Okay? So it's synergistic, it works together. All right, are we technologied out? Here's a little, at least it's moving and it's fun to watch. But have you heard about it's called the amiporine or the aquaporin proteins. These are cellular tunnels that are between cells that move water in and out. They also move other cellular signals. And why these are important is as you age again, you lose them. You lose the ability to move things through cells in between. There's an ingredient in the product that upregulates the expression of these proteins so that you have more of them. You have more water moving through the skin, and also cellular signals that tell it to repair and so forth. So this is the protein, and you can see these little red dots are the water moving through. So kind of interesting. Here's some pictures. Time 0, and then 56 days. Time 0, 56 days. See the difference in the wrinkles? Here and here. It's even more dramatic one next. Time 0 here. Deep, deep crow's feet. 28 days, 56 days. Also, I wanted to show you another thing really quick. This is a nerve and muscle co-culture, which is how we test these active ingredients on the nerve cells that we talked about. You see this is a muscle cell that's automatically contracting because it has a nerve cell with it. Now, we hit it with the material, it stops. And then when we wash the cells, it turns back on again. That explains the safety of it, that you wash it and it comes back. That's important, that's really important. And the other thing I wanted to show you was the immediate effect. This is brand new data. I got this less than a week ago. there's an ingredient, a high hyaluronic ingredient in our product. Time 0, this is 1 hour and 6 hours. So we're talking about an immediate effect of the product. This is pretty dramatic.